We've got now a talk by Sangarshanan, who has sent in a introduction to beatmaking with Python and FoxDot.
Hey everyone, I'm Sangarshanan, and thank you for coming to my talk, which is beatmaking with Python and FoxDot. So during the course of this talk, I will introduce FoxDot and how you can, use the flexibility of Python to make really good music. And in the process, we will also, write some code, make some good music with code, and, it'll end with like a really cool song that I'm going to demo in the end. So stick around, it's going to be fun. So before I get started with this talk, I just want to acknowledge some of the other really cool talks that were given in the same topic, which kind of inspired me to explore FoxDot and also give this talk. So shout out to Ryan Kirkbride, whose talk was at PyCon UK, and a shout out to Jessica Garson, whose PyCon talk was in 2019. So these two are really cool talks. So even after this talk, if you feel inspired to kind of know more about it and learn more about it, you should check out both of their talks. Cool. So here are some mandatory links that I want to attach. So the first one is to my repo, which has all the slides and the code that I'm going to demo during the course of this talk. And the second two optional links are to my Instagram and my SoundCloud, where I kind of upload my live coded music too. So I would appreciate any feedback, positive, negative, what you think. Let me know. Cool. What is live coding? Cool. Live coding is like this really awesome improvised performance art where you write code and use live coded tools like FoxDot. You also have tools like Hydra, P5JS, SonicPy, Tidal Cycles. You use all these amazing live coding tools to actually create music and visuals by writing code that's kind of projected on a screen. So people can actually see what you're doing. And as you do it live, people kind of interact with it. So it's a really niche. It started off as this really niche thing, but now there are like live coding communities around the world, and the movement is only getting like a lot bigger. So what is FoxDot? FoxDot is a live coding environment where you can actually write Python to make code. So what FoxDot kind of lets you do is it gives you like a computerized synthesizer. What is a synthesizer? How much time do you have? Synthesizer is not. It's just an electronic musical instrument that kind of looks like a keyboard, but it has a bunch of like tuner knobs where you can actually generate waveforms and you can tune those waveforms to sound different. So you have sine waves, you have square waves, you have sawtooth waveforms, and all of these waveforms just sound different. And you can use synthesizer to just create all these different waveforms. So it becomes like an infinite musical instrument. You can do like a lot of things. And FoxDot gives you the power of a synthesizer with Python. So you can just write Python to code up whatever you would do with your synthesizer, which is awesome. But how is FoxDot doing it? It's doing it with the help of this other really amazing software called Supercollider. And what FoxDot is just an abstraction on top of Supercollider with like a GUI. It has its own IDE, but in the end, it's just an abstraction on Supercollider. And Supercollider is the real hero. It is an amazing platform which is made up of like an audio server. It has its own interpreted programming language, which is also called Supercollider, and it also comes up with its own editor. And it has a whole bunch of plugins that you can install. You can build your own synthesizer with Supercollider. It's like super powerful, and it's also the base of a lot of live coding tools like FoxDot, Tidal Cycles, SonicPy. All of these kind of use Supercollider. It's also like free and open source, so it's awesome. That's awesome. Cool. So how do you install FoxDot? First, you need Python, which I'm guessing all of you would already have in your laptop. Apart from Python, you also need Supercollider. So you just go on to the website, Supercollider /downloads, install. the latest version, so 3.8 or above. And then you also need tkinter, which is the GUI, which kind of opens up FoxDot's UI. And along with that, you also just pip install FoxDot. And after you have everything set up, you open up Supercollider. Supercollider opens up an interface, and over there you just install this package called FoxDot. So packages or extensions in Supercollider is called quarks. So you just do quarks.install FoxDot, and then you just do a foxdot.start, which starts like a server, which means now you have FoxDot plugin installed and ready to connect on Supercollider. And now all you have to do is open your terminal and just go python-m foxdot or type foxdot if you're not in a virtual environment. And then you get this like nice IDE where you can write Python code to play around with. So it kind of looks something like this. So this is the IDE that pops up when I do, python-m foxdot. Cool. So the basic of kind of everything in FoxDot is a player, right? A player is what you can use to play anything you want. So we can define a player, say, let's say P1, and you define a player object, and you can name a player whatever you want it. And then you can hook it up to things. So over here, we are hooking it up to like a synthesizer, just like straight up. And our synth is called Prophet. So we have P1, which is the player. We're hooking it up to Prophet, and we are playing 0, 1, 2, 3, which are the notes that have to play. And then we can just stop this player by just doing P1.stop. That's it. Super easy. And then you can do like print synth devs to actually get like the list of synthesizers that are available for you. So it's not just Prophet. You have like pads, you have saw, you have like a bunch of synthesizers you can play around with in FoxDot. So actually, let's come to the notes. You see 0, 1, 2, 3 here. So what do these mean, right? So over here, the number 0 is actually the first or the root node, which is C. And it's followed by D, E, F, G, A, B. And going back by 1 will give you the notes that are below middle C. So -2 is the A that's actually below the middle C. So think of it like a piano where, note 0 is the middle C, and then you can count the white keys up or the white keys down, right? So what about the black keys? So you can actually just, it's actually very intuitive. 0.5 is going to be C sharp, and 1.5 is going to be like, the black key over here, D sharp. So it's like super intuitive where you just represent your piano as just integers. Cool. So now that we have a player, players have a bunch of attributes. So actually, to describe this better, I'm going to move ahead to my editor. Cool. So we have defined a player, and we have hooked up the synth to the player, and I'm going to just play it. And now I stopped it. So very cool. So it's just playing C, D, E, F, right? Which is the C major scale. So I can just switch the scale and I can play a different scale if I want to. So these are all the available synthesizers, which I don't think is going to be really clear to you. But yeah, it has like a whole bunch of synthesizers that you can use. It's not just going to be Prophet. So I can just do pluck, and it's going to sound different. It's a different synthesizer. Cool. So now coming up to player attributes that we just saw on the slide before. So a player is going to have like a bunch of attributes that you can pass that can control things when synth is playing, right? Like these knobs that you tune. Cool. So here are some of the player attributes. There are a lot of them, as I showed you on the slide, but these are some of them I'm going to explore. The first one is notes. Of course, it's going to be integers, so it's going to be like, D, E, F. So I'm just playing these notes, and then it's going to be the duration, which here is 1. So it gives like a 1 beat duration in between all these notes. But what do you mean by like a 1 beat duration? That is decided by the BPM, which I'm setting here as 120, which is like the tempo. So there's going to be like 120 beats per minute that they're going to be playing. And here is the octave. So if I play this, so it's octave 4. I make it octave 5. it's going to be 1 octave higher. So there are like a bunch of these parameters that I can tune. So like there's going to be delay, where how much should I wait before I play, and I can also mention my root, and a lot of other things. So this is like a really powerful way to just play a synthesizer, any synthesizer, by just writing code and passing an array and passing parameters. So how you write Python, you can just use the same way to make music. I find that really amazing. Uh, cool. But actually, the basis of making music is going to be patterns, right? Patterns are super important when you're making music. Cool. And FoxDot offers like a lot of ways where you can create patterns, because it's just a list, right? So there are a bunch of intuitive ways where you can create patterns. So you can do a shuffle, a reverse, swap, a rotate, a stretch, trim. You can also say like, in this pattern, for every 3 beats, just reverse it, and like FoxDot can do all that. So let's say I have this player and I have to play 0, 1, 2, 3, 0, 1, 2, 3 as notes, and I don't want to type all of this out. So I'm just going to define like a pattern object, and I'm going to say, play from 0 to 3, like how you would do list slicing. It's the same thing. It's Python list. So on top of Python list, you can also do a shuffle, which is going to just randomly shuffle whatever notes that you have, and you're going to also be able to do these every operation. So let's say I want 8, but after every 3 bars, I want to just like reverse it. So I can just do that also. Like, so the third one is going to be reversed. The first 2 is going to be like 1 to 8, 1 to 8, and then 8 to 1. So 1 to 8, 1 to 8, 8 to 1. So, after every 3 iterations, you just reverse it. And there is also like other things you can do. Swap, I can rotate, I can stretch, I can trim, and I can another very cool thing is I can also call a lambda function. So what I can do is I can just say, pads I have. Pads is my synth. Here is my pattern, which is going to be 8 notes, and I say like, uh, if the if my note is an even number, which means it's divisible by 2, then increase it by like an octave. It's like a very weird function. I can just write a lambda function for it, and I can just play it. Cool. I really like that. So you can do this gives you like a lot of power, because it's just Python, and you can write really complex functions which you can execute by just mapping it across your pattern. So you can create really cool patterns out of it. But how do you make sure like the pattern sounds good, right? So you can do that by playing the scale. So scales give you like a blueprint or a pattern of how notes should be ordered, right? So what we played initially, the keyboard that I showed you with just the white keys were 0, 1, 2, 3, men C, D, E, F, G, A, B, C. That's like the C major scale, right? Which is like the default scale in like Western music, and it's also the default scale in FoxDot. But you can also switch your scale, which means you can start from a different note, and the order of your notes is also going to be different. So your 0, 1, 2, 3 is not always going to be C, D, E, F. It's going to change depending on what scale you're on. So let's say I am playing the Lydian scale. So this is a much different scale than what the C major scale is. And scales can also be used to represent emotions. So we would just say maybe a major scale sounds really happy to you, a minor scale might sound somber or like sad, but actually that's debatable. It depends on how you play the scale. You can make a minor scale sound really happy by just playing the notes in the right order. But scales have emotions associated with it inherently. So you can use scales to control the those emotions that you evoke with your music. But you know what? Let's say, like for me personally, I don't really know a lot of music theory, so I'm oblivious as to like how do I play notes. So what I do is I actually look at all of the scales that are there, right? And I just pick a scale and I create melodies by actually randomizing my choice over a loop. So I just say, pick a random note in a particular octave in a Dorian scale, and just randomize my duration between 0 to 1, right? And is just a melody. It's a melody that it's just random melodies, and it's going to be random every time you play it. Nice. So this is awesome. So you can just randomize things and play notes. And rather than doing this random dot choice across with a list comprehension, we can actually do a random pattern. So FoxDot also has, uh, abstractions for things that you would commonly do. So rather than doing this, you can just type a random pattern among 4 notes, just pick something random. And what I'm doing here is I'm changing synth every time I'm playing, and I'm taking from the list of synth definitions. So every time I play this, I'm going to have a different synth. So let's try it out. So every time I play it, it's going to play the same kind of notes, but in like a different synth. So again, I'm increasing the possibilities of randomness here, and you can just layer it on top of each other, and you can make really cool stuff. Right, awesome. So now we know what patterns are. Now we know how to play notes. Now we know how to play synths. Now we also know some of the attributes, randomizations, melodies, and stuff. And now comes one of my most favorite parts about FoxDot, and why I think FoxDot is as powerful as it is, which is time variables. So time variables kind of are these variables that you define by just defining a variable. You pass a list of values and you pass a list of durations, and these values change after a predefined number of beats, which is set by the duration, right? So let's say I have this a, which I'm defining as a variable, which is going to be 0 and 4, and my duration is 2. So after every second beat, my variable is going to switch to 4. So it's going to be 0, after 2 beats, 4, right? So I can actually do this to do live coding, because that's what live coding is, progressively change things as time moves ahead. So time variables kind of let you do these things. You can do this to create chord progressions, or if you want to switch to a new scale after every 16 beats or every 8 beats, you can do these things like that by time variables, which I think is really awesome. So let's check out how we do that. Cool. So let's say that we have defined this variable where the integers are going to be 0, 5, 1, 2, which are notes, but 0 will play after 2 beats, 5 after 1 beat, 1 after 2 beats, and 3 after 1 beat. So these are going to be like the durations after which the variable should trigger, these things, these notes. So if I'm going to just play this, so you hear notes kind of played multiple times because there's gap between those beats, and the ones that kind of play more frequently, you're going to hear them multiple times, right? Like say 5 and 3 are what you're hearing, multiple times. So this is just a simple way to tune time variables, but there are also advanced time variables, you have linear variables where you can actually linearly increase the value by just doing a lin var of 0 to 1 for I think 8 bars. So you can just increase it gradually from 0 to 1. So let's say I'm playing notes 3 to 5, and I want to just linearly increase, as I go to 8 beats from 0 to 1. It's going to sound something like this. I kind of think this sounds like an ambulance, like an effect of a thing that's kind of moving in front of you. And the fact that you can do this with linear variables is super cool, and you don't have to kind of manually, have a for loop for I in every iteration of the particular beat, linearly incremented by some value, and then again decremented. You don't have to do all that, and you can just do a linvar, and FoxDot inherently handles that for you. I think that's pretty cool. Cool. So again, time variables, awesome utilities. But what I think also makes FoxDot really powerful is the ability to use samples. So FoxDot has inherently a bunch of samples that you can use out of the box. Cool. So you come to samples when we have just explored these notes and we want to add some juju to our music. That's when we come to samples, and FoxDot has like a bunch of samples that we just printed right now. Uh, so I think you cannot see a lot of all these samples, but you can have things like a kick, a snare, a hi-hat, a random voice, some random noise, metal clanking, uh, you know, you know, just random noises. So what you can do now is, let's say I want to play a kick, right? Uh, let's say I want to play a kick and a snare. Cool. Now I want to add a hi-hat. Now let's add another hi-hat. So this is actually the 4x4 four on the floor disco beat that you hear in like a lot of disco songs from the 80s and even now actually. But then 4x4 doesn't play as it is. So right now we have just played one players, but you can actually layer players on top of each other and you can have two players. So let's say D1 is playing 4x4, and with D2 I want to add like some magic, add some layers to a to a generic 4x4 beat, right? So let me just try to do some of that. So 4x4 beat, I'm adding an open symbol. So you can just add some layers on top of beats and just keep on adding layers and removing them, and that's what makes FoxDot so powerful and amazing to make beats. Cool. So these are just really simple beats, right? So I want to go a little bit more complex, right? So you have these brackets, round brackets. So you use these round brackets when you want to play things as if they were one character, which doesn't really make sense, maybe. So let me just sonically show you how that works. So you have okay, I'm going to something weird. You have right. So if you want to do right, so let's say you have this one note and you have two notes here and there. You don't want to play them linearly. You want to play them like they were individual notes, right? So that's what you can do with a round bracket. So let me just show you how it happens, and now that I think you'll get it. This is before. This is after. So this is how you can just create patterns without even with just minimal amount of code, right? And another bracket that you can use, the brackets are what it uses to actually create these patterns. There's actually also the square bracket, and square bracket can be used to play things twice as fast. So let's say I have these two hi-hats that play at normal pace and three of these hi-hats that play kind of double the speed. Cool. So this kind of things sounds like a trap beat, right? So I'm going to add some drum to it. So yeah, so you can just add stuff and make it like a trap beat. Cool. So now that we explored, round bracket and square bracket, there is also these chorical brackets that you can use to play multiple sequences using just one string. So let's say you have this beat, right? And you have this beat. So they sound really well together, right? But you have to write two different lines to actually execute them. And if you want to play them in the same line, you can just use these brackets and just write them together, and they will play independently as, two separate sequences. Now to add some juju to it. Cool. This is how you kind of make beats in FoxDot. So you can just add more complex patterns, rhythms, notes, beats, bass, and all of this is what makes up a live coded musical performance. Now that we covered most of it, let's actually make a cover, right? So I'm going to set my BPM to 120, and I'm going to play like a basic drum beat. Cool. So now I have my bass that I have already defined my notes for. I'm going to play it. Cool. All right. This is me. Thank you so much for attending this talk. I hope you had fun. I hope you learned something new, and I hope you explore FoxDot to make some music of your own. And if you do, please share it with me. I would love to hear it. And thank you so much.
Thank you, Sangarshanan. If you've enjoyed this talk, you'll be able to find Sangarshanan on the Discord to ask any questions that you have. We've got a bit of a break, but then coming up down in room C will be the lightning talks.